All right, and we're going to start with a news story. And so today, everybody close your Chromebooks. We're gonna have a nice discussion with everybody focusing on past. I got a quick little news story that I want to bring to y'all's attention because uh, I think it's weird and interesting, and I like weird and interesting things. And I think it's one of like when I was growing up, adults like kind of poo-pooed certain things, and then as an adult I see that those things are real now. So like many things that I heard while growing up is like, no one's gonna pay you to skateboard or rollerblade. That's just something you do for fun. That's not a job. Which you probably heard about video games, right? No one's gonna pay you to play video games. That's not a job. You need to think about going to college, which you should think about going to college, but don't think that playing video games is not a job. Obviously, it is. Another thing, like no one, you're just spray painting. That's not art. You're just destroying property and vandalizing things. Literally, the most famous painter in the world right now spray paints on buildings. That's his thing, and that's what he's done. And so I think we can all recognize that the ability of adults to gauge the popularity of futuristic kind of things is none. And so my wife brings this news story to my attention like a couple days ago. She's like, the NBA is selling digital moments. Like they're basically trying to create digital trading cards in a way. So instead of buying like a piece of paper with someone's picture on it, and some stats on the back, the NBA is selling digital highlights. So you pay a certain amount of money. It depends on the highlight and the player and the moment. And the NBA is saying that this is a limited purchase. So, like, let's say they've got this sweet highlight of Luka like draining a three over somebody, and they only make 300 of those. And you can buy them, but there'll only ever be 300. Well, that's one of the things that kind of gives it value, because like what's valuable about the most valuable trading cards? They're extremely rare. You're one of only a couple people that has it, and someone's gonna buy it because that athlete just won a championship, or they just retired, or something big just happened in their career. Now the amount of that card just went up, and so it's there. But I don't know that everybody's going to be online with the digital portion of it. I can't hold it in my hands. Like I can't lock it in a safe somewhere. It's just like a digital copy. And so now is where it gets a little bit more in depth. So this all has a relationship to Bitcoin and blockchain. And in order to understand exactly what's going on here, you have to have a pretty good understanding of what Bitcoin is and what blockchain is, and the security and kind of computer requirements for that stuff. So I want to just go over it a little bit and talk to y'all about what's going on. So the NBA has obviously had a little bit of success for this. Mark Cuban is backing it. They've raised $230 million at least so far selling these highlights in digital format. I saw on the news this morning or yesterday, probably because I look up a lot of SpaceX stuff. Probably because I look up a lot of SpaceX stuff, and Grimes and Elon Musk are dating right now and have a child together. But Grimes sold $6 million worth of really weird off-the-wall art in this digital format, and it's actually pretty cool. It's not my favorite kind of art, but it's really out there, and it's cool to see the artists in digital media getting a way to actually make themselves a top tier artist. Because you could say like someone could spend like months building a scene, like a digital scene online, like you would see in a movie or like you would see in a commercial. But unless you sell it to a movie or a commercial, there's no outlet for that. How do you sell like a video clip for $50,000 to someone online, like a painter would with a canvas in like an art show? And so this kind of opens that up in that way. this is not the proper news article. They had another video and a different one. But she sold some things that only had one single copy. She sold some things that had hundreds of copies or thousands of copies. For example, there were these two short video pieces, one of them called Earth and one of them called Mars, so they kind of went together. And she sold 300 copies at $7,500 a piece. And apparently, that's it. Those 300 copies are it. There won't be any more copies anywhere else. And I assume because you're selling this to people, you can't just like hop on the internet and watch all this stuff. Some of it maybe you can, but why would someone pay $7,500 for something that they can just get on YouTube? It's got to be somewhat private. It's got to be somewhat like limited. And so here comes the blockchain part. What, like, if it's not a physical thing that I can hold and keep and like put on my wall or put in a safe, how do I make sure that it just doesn't get copied? How do I know as one of these 300 buyers that number 299 isn't just going to post pictures of theirs online or make a copy of the video and give it to anybody who wants it? That's where you get into blockchain and unique like digital signatures that not only cannot be hacked or ideally cannot be hacked, but are shared between everybody. And so the idea of blockchain is I have this like super unique, crazy password that tells the entire internet that this thing is mine. But not only that, it's not just on my computer, it's on every single computer in the system. So if you wanted to like come in and hack my video of Luca or of Grimes or whatever it is, you can't just hack my computer and get it. You'd have to hack literally the entire system, thousands of computers at a time, and change them all simultaneously, which is supposed to be impossible. And so it's really weird. It's crazy. I don't fully understand it. I don't even know if people like Mark Cuban and the people in the NBA that are pushing it fully understand it. And there's a lot of weirdness to it. So like Grimes, who's dating Elon Musk, they're both very conscious about the environment and about global warming and what's going on. Somewhere in this article, it mentions that she's donating some of the proceeds to like carbon offset. And they're like, well, this actually, these kind of blockchain things are extremely wasteful in electricity because it requires super powerful computers to work for very long periods of time to come up with these blockchains. And does anybody like game pretty heavily at home? No gamers in this class. It's fine. If you were a gamer, you'd know that blockchain has made things vastly more expensive for gamers. Because if you want to buy a graphics card now, you're not competing with other internet gamers. You're competing with Bitcoin mining companies that are buying up all of these graphics cards. So they're really hard to get and they're really expensive. Because there's a new market for them outside of people who just want high frame rate shooting games, you know? And so there's all sorts of layers to this. I feel like there's a whole generation of dads out there who collected like paper baseball cards that are going to be like, what is this? Like, this is trash. No one's going to pay for like a digital video clip. But the truth is people are already paying for it. And I feel like this is the, like, one of those things. I don't know that it's going to be like Bitcoin where it's actually going to be valuable, but I think this is one of those things where 5 or 10 years from now, people will look back on it. Certain people will look back on it and be like, wow, I wish I'd gotten into that immediately. Or I wish I'd known what's going on then and kind of had a better grasp of it because now it's like blowing up and this is the new thing. And so there's lots of news articles now. She's done it. She's a musician slash like traditional, not traditional as far as media, but she makes art, like different art that's kind of stuff you'd probably see in like an art gallery, as well as being a musician. The NBA is doing it with highlights and video moments, similar to like a playing card kind of thing. And it looks like all sorts of other people are about to get into it. And so if you see this term NFT, that's what they're talking about. Like digital media protected by the blockchain. I don't know what fungible means, but it stands for non-fungible tokens, which is like a Bitcoin thing. So I don't know. I don't know what this is. I don't know what this means. If you got,
sounds like rich people finding ways to get richer.
Yeah.
well, yes, but I think there's a lot. All of the big stuff is always going to be rich people trying to get more richer. But I think there's some underlying things here that are going to infiltrate different parts of culture, and especially when you get into new art. And I feel like there's a lot of new art going out there in digital media that just we haven't found a way to treat it like old art, like paintings and drawings, and things that I can physically hold. If someone makes it on a computer and it can be easily copied, I think it inherently, for the art world, has less value, and that probably shouldn't be a thing. Hello? Yes. Yes, no problem. Okay. Taylor, Miss Jones wants to see you. Okay, so I don't know if you see anything about this, hear about this, know somebody that bought one. I'd be interested to hear about it because I think it's interesting, and I think it could be something that we all look back on and go, wow, that was kind of like a change in this particular area of entertainment or media. I don't know. So that's my little news story for today. What we're gonna do now, we're gonna try to quickly burn through half this PowerPoint because we've gone over a lot of this stuff before, but we need to go on to the next chapter. So we're starting with volcanoes. And let me hit big screen. I got my little laser pointer to flip through the slides now. I'm all fancy. So we start with the Icelandic volcano. Does anybody want to try to pronounce that?
Oh, this is the one you're like, oh, we're going to try it now.
Yeah, I forget if I do this like the first semester or the second semester. And then even first period, I went a couple slides in and I was like, these are the first semester slides because they're repeating a bunch of stuff. And I had to go and check and it wasn't. But yes, this is an Icelandic volcano. It's very difficult for us to pronounce. A lot of us, we don't have the palate construction to make these sounds with our mouths. There's a lot of K's and L's and J's like all packed in there together. But that's the name of the Icelandic volcano that they're talking about here. And I actually remember this one, and I may have talked about this last semester. I remember this happening because of the shutdown of airplanes. When you shut down airplanes for like all of Europe for weeks at a time, it's going to be all over the news. People are going to talk about it a bunch. And so I very much remember this volcano happening. It erupted in April 2010. A huge ash plume about 6 miles high went over Europe and basically shut down airspace in Europe. It was the largest airspace closure in Europe since World War II. So literally since Europe was just literally getting destroyed everywhere, have we not had a closure of airplanes this large. And it was a volcano that's not even in Europe. It's across the ocean. Not super far away, but not like right next door either. So they did have a little increased seismic activity a year before in December 2009, and then you eventually have your eruptions. There were some fissure eruptions that were small, and they're trying to explore what happened so they can kind of have a better understanding and maybe predict a little bit more. Here's the nice ash cloud coming out, and then you can see in this map, this is Europe, mainland Europe. You've got England and Ireland and the Nordic Peninsula up here. And then you can see your ash clouds moving down over Europe, and it caused a lot of disruption because you do not want to fly your plane through an ash cloud. It's going to mess up your engines. It's going to cause a lot of problems. And we have this nice fire and ice picture with your lava coming down and reaching the ocean and your glacier coming down and kind of meeting at the same point. So you got a little bit of both going on in Iceland. Yes, hello.
I'm still on.
Okay, I appreciate it. Volcanic activity is directly related to plate tectonics. We just want to remember that it's all about plate tectonics. There are very few volcanoes that aren't right on the plate boundary. Your exceptions are going to be Hawaii, right in the middle of the Pacific Ocean, or like Yosemite, Yellowstone, which is our other super volcano right in like Montana, Wyoming kind of area. So those aren't right at plate boundaries, but almost everything else is. 2/3 of the volcanoes are right around the Ring of Fire in the Pacific Ocean. Oh, I'm going the wrong way. So here's your Ring of Fire there. Most of your volcanoes are here. I'm flipping slides a lot, being all willy-nilly. You got Hawaii right here in the middle of the Pacific Ocean. You have your Yosemite volcano, which they don't even have on the map here. And then there's a couple others. Here's your Icelandic volcano, right at your rift between the North American plate and the Eurasian plate. And then you have this volcanic rift right here where Africa tried to tear itself apart. And even the Arabian Peninsula kind of succeeded and tore itself off and is headed up into Eurasia. And you've got a string of volcanoes where those two plates kind of separated. So volcanoes at plate boundaries, extremely common. Volcanoes within plates are going to be less common and less of a hazard in a way. So this we're going to skip over a lot. They talk about how magma forms, which you've already done. They talk about different properties of magma, which we've gone through. They talk about the different types of volcanoes, which we've gone through. Do I want to go back to that one? No, these are different types of volcanoes. We've already gone through this. And then we get to 5.3, risk. This is what we want to talk about. So, places in direct volcanic risk, anywhere around the Ring of Fire. If you're around the edge of the Pacific Ocean, you live right next to a volcano, and you're probably very aware of it. Some other places are hotspots like Hawaii and Yellowstone Park. Yellowstone does not erupt very often, and when it does, it's probably going to be a big eruption. We'll talk about that in a second. Hawaii erupts extremely frequently and has very little deaths because it's a slow eruption, and the people that live there are very used to it, so there's not a lot of surprises. You can have eruptions on mid-ocean ridges like Iceland. Most of the time, those eruptions happen under the ocean. So on the rare occasion you have a mid-ocean ridge that happens on land like Iceland, there you're going to get your volcanoes that are up above the sea level. And then in your rift valleys, like I pointed out, Eastern Africa, where the Arabian Peninsula kind of pulled away there. This is just like a volcano map for the United States. Oregon and Washington are going to be your two hotspots in the mainland. Alaska has the most volcanoes and the most eruptions for the United States. Mid to northern California does have a couple, although I believe they're not really as active as the ones that are a little bit further north. So let's see. 50 to 60 volcanoes erupt each year worldwide. If I had to guess, like if you just asked me off the street how many volcanoes erupt worldwide a year, I'd guess maybe more than 50 or 60. That being said, if you told me 2 to 3 volcanoes erupt every year in the United States, I would maybe think that would be lower because we don't hear about them that much. But that's mostly because they're in Alaska. Way far away. Nobody lives in that part of Alaska. It's just like a string of volcanoes out in the Pacific Ocean. And the eruptions don't really affect people all that much. So most of the eruptions are in sparsely populated regions. But there are areas where a lot of people live right on the volcanoes. So like Japan, they don't have a choice. If you live anywhere in Japan, you're living on a volcano. All of the island is volcanoes. Mexico City, I believe, is on top of a giant volcano. I don't think it erupts very often, but I don't think it's dead either. And so if that ever erupts, that's going to be bad news there. The Philippines and Indonesia, pretty much all of your Pacific islands are all just volcanic islands. Every single island is just a different volcano. And so their entire existence, along with Hawaiians, have just been related to these volcanoes. Several U.S. cities are vulnerable. Your Pacific Northwest cities, Seattle is just surrounded by volcanoes. All of those cities up there are just surrounded by volcanoes. And so if any one of them goes off, you have a likelihood of being affected by it. We're familiar with the primary effects. Lava, ashfall, pyroclastic flows, blast out the side of your volcano like Mount St. Helens, and then some release of gases, usually poisonous gases, that can maybe contribute to acid rain. Secondary effects are going to be huge, though, and we'll see that in a second. Debris flows, mud flows, landslides, debris avalanches, floods, fires, and tsunamis can all be secondary effects of volcanoes and can sometimes cause more problems for humans than the actual volcano itself. Global cooling of the atmosphere in a large eruption is a thing. And in fact, going back into geologic history, the times when we have lots and lots and lots of volcanic eruptions, at least my brain thinks it should be hotter. Like with like lava spewing out all over the earth, you'd think that would be like a warmer period. But in reality, the heat that lava is bringing to the surface is minuscule compared to the heat that we're losing from the sun not getting to the surface from all the ash in the atmosphere. And so when we have high events of volcanic activity, the global temperature usually goes down because we have so much ash in the air kind of blocking out the sun. So just something to keep in mind then. This is a list of volcanoes. At the bottom, we have our Icelandic volcano that we were talking about in 2010. Right here in 1980, you can see Mount St. Helens. And I'll point out, the Mount St. Helens eruption had very few deaths. In that part of Washington, it's really difficult to live up on the mountain. And so people live a little bit further down. The cities are kind of down around the base. We've got a lot of infrastructure there. They had a decent amount of warning time, and the explosion didn't really go towards any highly populated areas. And so 57 people died, and it destroyed more than 100 homes, which isn't too bad, all things considering. And then you go down just 5 years later in Colombia, you have a volcanic eruption, and it's not even the volcano that causes the problem, but you have a mud flow that comes through and hits the town, and 22,000 people die from the mud, not from the volcano itself. And so your secondary effects can be devastating in the right situation. And so just looking at some of these, we've got a lot of different ones. Obviously, outside of the United States volcanoes and your Icelandic volcano, which I don't think had any deaths, they picked some of the really bad ones. So at the top, you see Pompeii up here, and we're going to talk about Pompeii a little bit. The amazing thing about Pompeii is, to me, outside of like the science of it, is just the fact that a volcano could wipe a town from human memory. That literally this volcano happened in 79 AD, and we didn't even know the town existed until over 1,500 years later. This volcano wiped the history of this town. And if we hadn't dug in the ground here and found this town, we might still not know about it today. And that's just crazy to me that, like, people down the road, there had to have been somebody that visited that town that wasn't there that day. And they weren't like, hey, there used to be a town there and now there's not. Where did all those people go? So within a short period of time, it seems like everybody who ever knew about this town died, and it was just lost to memory until we stumbled upon it 1,500 years ago. And it wasn't a small town. They had art. They had lots of different buildings. They had it was a kind of metropolis with a whole bunch of different stuff going on. And it just kind of got wiped out, which is crazy, 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 crazy. So there's a lot of stuff to learn from these volcanoes. And obviously we don't want history to repeat itself. So we're trying to figure out what we can do better. Here's Alaska, and these are your Alaskan volcanoes. This is why I say Alaska has the most eruptions in the United States, but it doesn't really affect that many people. Because, from here on out, you probably have people living on this peninsula in the tens or hundreds, not in the thousands. This is a very difficult area to live. You're probably a survivalist if you're living out here. Even in your big towns like Anchorage, you have very small populations comparatively. And so it's not really affecting humans all that much. Hawaii, different story. Lots of people living on Hawaii, big vacation area, and you're in close proximity to the volcanoes. You can't really get away from it. Here's a couple volcanoes mid to Northern California. You got 3 in Oregon and 4 in Washington, not including Yellowstone over here near Montana and Wyoming. And so we got some volcanoes there. You do have a couple in Arizona and New Mexico. I think they're mostly extinct and not going to come back. But if you ever want to visit a volcano and climb one, it's not too big. A volcano you can climb in a day. Arizona, New Mexico is a place you should go. Lava flows. They talk about the different types of lava flows, and we kind of went over this before. Your basaltic, darker rock is going to have a nice, easy lava flow that's just going to roll down the hill slowly, like Hawaii. Rhyolitic lava is going to be explosive. You're talking Mount St. Helens, you're talking Pompeii, and you can even find some really old rhyolitic volcanic rock in Oklahoma. Oklahoma had quite a few volcanoes that spit out this nice pink rock. And then lava tubes. There's a picture of a lava tube in a second. I've seen lava tubes that you can tour in California. I have never been to California or been to a lava tube, but I assume it would be good to tell you if you ever get the chance to go in. I would go in. And then I know that I've mentioned before, lava tubes are likely going to be the first moon base, because if I'm building a dome that's going to hold all my air in, one little rock can pop a hole in and we all suffocate. That's not a good idea. And digging a hole on the moon is going to be kind of tough. So what if we just use a hole that's already there, and we live in the lava tubes? That could be a better plan, and I think we may end up doing that. Your lava can move slowly or more rapidly. Your pahoehoe and your are generally going to be pretty slow. When your house is going to get destroyed by lava in Hawaii, you usually get like at least a couple days, maybe a couple weeks warning. They're like, hey, the lava river has changed course and it's coming over the hill, and we really need you to pack up all your stuff and kind of be gone by Wednesday, and we're going to evacuate you. And then it just slowly comes. And so you can see this person standing just a couple feet away from the lava. The house is on fire, but it doesn't appear that anybody's life was in danger immediately. They probably had plenty of time to clear everything out, get their stuff moved. And so at the very least, it's very disruptive to your life, but you still have your family. No one's died, and you were able to kind of secure some things. The is going to be the same thing. It's just a giant, like rolling, blocky piece of lava that's going to slowly move towards the ocean. Another example, nice and calm. This guy is not in fear for his life. He's got his lava stick with a little cup on the end. He's going to stick his lava stick down in the hole and scoop up a cup of lava and pour it into a bucket and take it back to the lab to do some work. And here's a nice lava tube. It just looks like a cave, but at one point in time, this was filled with molten lava, all flowing out towards the surface, and you can go in and tour that. If I was in there, I would be awesome. I would constantly be looking over my shoulder for like the rolling wave of lava to come and take me, because you never know. But I think it'd be pretty cool. So that's kind of what you have right here. This lava is being pushed up through like a tube, or it could be falling down a tube, depending on which way it's going. But ultimately, when the volcano kind of subsides, that tube will empty out. And if you're brave enough, you can venture down there. Let's see. Explosive pyroclastic material. All sorts of stuff can come from a volcanic explosion. Really fine stuff, medium-sized stuff, or giant blocks. And to bring this back to Pompeii, there was a news story a year ago, maybe, about a thing they found in Pompeii that looked like a person had been crushed by a volcanic block. Let's see if I can pull this up. That's not too big. View image. There we go. And so they found this skeleton, and clearly the upper half of the skeleton is crushed by this giant block. The idea was this was an unfortunate soul who was close to Pompeii at the time, but not actually in the town, so he wasn't killed by the initial blast of the volcano. He was a little bit further away or in a different direction, but he's like strolling along, and this giant block comes and crushes him. And so I don't believe they figured out, I don't believe that's what actually happened. I think they think that the person was deceased first, and then the block came and landed on top of their deceased body, whether it was covered or not, I don't know. Yeah, just to make sure the volcano sent a giant block for you. But it kind of shows you the size of pieces that can come off of a volcano when literally like the whole mountain explodes. And so it could be small pieces. It could be ash, just fine little ash. It could be a giant boulder flying hundreds of meters or thousands of meters through the air just to land on something unwittingly. So That's just an example of the type of blocks that can be thrown from a giant volcano. Let's see. They got a nice demonstration or a diagram of your volcanic ash coming up, falling down, your pyroclastic flow coming down the side. You've got a lahar mud flow. This would be similar to the mud flow that devastated that Colombian town that killed 22,000 people. More than likely, you had like a crater lake up at the top of the volcano where your crater gets filled in with ice and snow. It creates a nice lake. When your eruption happens, that water's got to go downhill somewhere, and so it mixes with the ash and flows downhill. And even if the volcano itself doesn't get you, the mud flow could. And we'll see that in a second on a volcano diagram. So let's see. They talk about ashfall. It can mess up your vegetation if you have a food producing area, farms. What am I trying to?
Farmland?
Farmland. There you go. I'm like, what's the area where you have farms at? What do you call that? Thank you. Farmland. So yeah, if you're in like an agriculture area, you're gonna have some issues from ashfall and from acid rain. Surface water could be contaminated by all your ash and all your sediment. And you even see in a little while we'll see a lake that's clogged up with trees near Mount St. Helens. Here's a town that's been kind of overrun by ash and tephra. This is going to be thicker than ash. This is going to be more close to like gravel size stuff. And so this is devastating for a town. You're not going to be able to like snow shovel your way out of this. If this town is salvageable, which I'm not familiar with this town or whether people live here now, you're talking about cleaning this out with bulldozers over weeks or months, not just like a quick cleanup. And to be honest, how long are you going to have before this happens again? It depends on the activity of your volcano, but this could be a town that you abandon, depending on how bad this is. But lots and lots of ash built up over these houses. This is not a good time here. Then they talk about pyroclastic flows. Remember that some of your hot ash does not go up. Some of it comes down. It's very dense. It moves very, very quickly with a really high temperature. So 250 miles an hour of steaming hot gas coming down. This is what hit the people of Pompeii. And most of us have seen the pictures of the people of Pompeii. We will see one in a second. But this is the devastation that you get. It's going to knock over trees. It's going to flatten buildings. And it's going to kind of like instantly incinerate anything in its path until it kind of runs out of steam. So this is an actual picture of a pyroclastic flow. You see the ash cloud going up. You see the hot, steaming pyroclastic flow coming down and just kind of taking out everything in its path. Here's a picture of some unfortunate people from Pompeii. And again, like we see these pictures and obviously the visual images here are unnerving. It's scary to think about being those people and having that happen in an instant. Everything, not just your personal life, your entire town, everything about your life that you knew is wiped out. And not just taken from you, literally hidden from the world. Your town was wiped from history for 1,000 years before it was rediscovered. It's crazy. It's crazy to think about. It's crazy to think like, imagine a U.S. town getting hit by a hurricane and us just forgetting that it existed ever. It's a crazy thing to happen, and I don't know that it would happen again, but it's incredible to think about. So yes, this is very common in Pompeii, and they've been finding crazy things ever since. Just this week, someone found this like crazy extravagant like a horse-pulled carriage. I don't know if it's a horse-pulled carriage, but it's like the limo for people that lived in Pompeii. It's like super long and fancy and extravagant, and they just found it, I think, this week maybe. And there's a bunch of news stories about it. So let's see. They talk about gases that are emitted. Carbon dioxide is going to be a big one. That's going to contribute to global warming if you can. It's going to create some local effects. Sulfur dioxide can produce acid rain, which is also going to affect your farming economy. Toxic concentrations rarely reach populated areas. It kind of spreads out and causes a little bit here and there. Combined with the ash, it can really affect your soil and your plants. They talk about lahars. Lahars are going to be your mud flows. So remember that if your ash mixes with water, it's all going to go downhill at some point, and you're going to have problems from it. And so I can't see where the volcano is here, but this is probably some sort of lake, or judging by the hills, I doubt it was ice or snow. So probably some sort of lake that was released by a volcano erupting. It either broke the dam or it's a big crater lake or something. And you can see for this town, for the people in this town, there's no dry area right now. Maybe you might be in a second-story building, kind of waiting this out, but there's really not anywhere for you to go. And it even looks like the hills are kind of cut off by the river that's coming through. And so whoever's in this town is probably in a pretty rough spot right now. And this is a map of Mount Rainier. And this kind of shows you, even if you're not close to the volcano, you have some things to worry about. So if Mount Rainier erupts, one of the rivers they're going to be keeping an eye on is this Puyallup River, I guess. Puyallup, I guess. If a lahar comes down this river, it's going to take out no less than 3 towns. And it's going to head towards Tacoma. And if you've ever been in this area, like this entire area is just nonstop packed houses, elbow to elbow. This is extremely developed. Everything around the Puget Sound is. And Tacoma is a huge, huge city with several military bases and lots of stuff going on there.
And our airport is in Tacoma.
Yes, the airport. Yeah. SeaTac is in Tacoma. Yeah. And so extremely populated, and that's where your lahar is going to head, which would be bad for that area. The next slide, unfortunately, it says the 2010 Iceland eruption, but they're actually talking about 1980 Mount St. Helens. So they kind of go through this. They show you the volcano before, and then they show you the collapsed flank, how everything slid down this way. You can see all the trees, even this far away, just flattened by that pyroclastic blast. The lake is choked up and clogged with dead trees that have just been knocked out into the lake. And so this is probably fairly recently after the eruption happened, but really, really bad devastation for a very long period. They say it was dormant for a long time, 120 years. It erupted in May. It started to have some activity in March. May 1st, they start to see the bulge happening, and the bulge is well documented. You can see the volcano like start to flex out like a balloon almost as it's getting filled up with lava. And then ultimately something cracks, you have an earthquake, and you have your big eruption that happens. Couple picture sequences here. It's still amazing to me that, I mean, it's 1980, so we weren't like super advanced, but no video of this. Only a few people that took some rare pictures, but no video of the Mount St. Helens eruption, which is a little disappointing for me personally. Let's see. This also shows that because the mountain collapsed, most of the destruction went in one direction. So if you're on the backside of the mountain, I'm sure it wasn't a fun time, but you didn't get like pyroclastic flow and lava and lots of debris. It pretty much went that direction. And then the ash spread out across the entire United States, although not every state got a bunch of it. But even extreme portions of Texas got a little bit of ash from this Mount St. Helens eruption. And so I thought it was before this, but in a second, they kind of get to, at some point in time, they talked about the Yellowstone eruption. And so I'd like to go back to that real quick before the bell rings, if I can. Maybe I lost the slide. There it is. So every once in a while you hear a news story about, is Yellowstone going to erupt? It's a super volcano. We're all going to die. The truth is it's going to be bad. If Yellowstone erupts, it will change life in the United States permanently, at least for our lifetimes. But we're not in danger in Texas. We could get some ash for sure. The last time it erupted, we got plenty of ash here in Texas. And the last time it erupted, here's the real crazy part. you can see, and this picture's not even designed to show this, you can see the river of lava that came out of the Yellowstone volcano and went all the way to the ocean. It's just nothing but like a basaltic floodplain here. And so if that happens in a similar way, you're talking about a lot of people from these states right here being displaced. Montana, Idaho, Wyoming, not traditionally high population states, although any population having to move to a different state is going to be somewhat disruptive. But yeah, if you flow through Oregon here and take out a couple major towns on the West Coast, that's going to mean thousands and thousands and thousands of people having to relocate, move their businesses, their homes, well, not move their homes, but move their lives. And that can be tough to handle for different economies. We've seen in Texas the effects it has on us when a hurricane hits Louisiana. People move out. They don't move back to Louisiana. And now you have housing issues. You have job issues. It takes a little while for the economies to kind of rebalance out. And so there's nothing we can do about this, but know that it's not going to be like country ending or world ending. But it will be something we have to adjust to, and we have to figure out kind of how to live our lives alongside that. So that's where we're going to leave it off for today. We're at least halfway through, and we should be able to finish it up tomorrow. So wonderful. Great job, everybody. And we're inching closer. We're inching closer.